This is chapter 8, part 3, and it's still about how to subnet a IPv4 network. Now I will try to show you, just to give you an idea of how to do it, when I have a /16 and a /8 prefix, which means that I have really huge networks and how to subnet those. So if I have a /16 and then I borrow 1 bit and I now have a /17, well, then I have 2 new subnets and I have 32,564 host addresses. And this is because I originally have 65,000 something, and then now I divide them in 2, and -2 of course also when I have the number of hosts. And then you can see borrowing 2 bits gives me a /18, and with 16,000 something hosts, /19 give me 8 new networks with 8,190, and so on. So then I will have, depending on how many networks I will, or how many bits I will borrow, will give me the number of new networks. For instance, if I borrow, like here, I borrow 8, 9, 10, 11 new bits, then I will get 2,048 new networks, and so on. But the same thing here applies. The number of networks will give me, the number of bits I borrow will give me the number of new networks that I create. And again, in the 2 in the power of n, where n is the number of bits borrowed. And here, for instance, if I have a /16 network from the beginning and I borrow 7 bits, that will create 128 new subnets. And now you can see here, this is a /16 when I begin with, and then I borrow these first 7 bits of the host portion of the IP address. And then, of course, to find the 128 new subnets, I take the first one, will be all zeros, and then it will be zeros and a 1 and 1 and 0 and 1 and 1 and 0 0 and so on. Then I keep, all the different variations of 7 bits, and then I will get all the new networks that I will create. And putting them back into decimal numbers will give me 172.16.00/23, 172.16.2/20/23, 40/23, and up to 254.0/23. So it's basically just doing the hard binary work and calculating all of them. So how many host addresses have I room for in each and every one of these? Well, I have now 9 bits remaining for the host, because I had originally 16. I borrowed 7 of them. That gives me 9 bits left for the host. So 2 in the power of 9 will now be 512 minus 2. So I have room for 510 host addresses in each of these 128 networks. And even more wild is when I have a /8 network and I want to subnet that. For instance, I borrow 10 bits, and that will create 1,024 new subnets, because 2 in the power of 10 is 1,024. And the same thing applies here. I take the bits that I borrowed and vary them over all the different variations. So all of them 0, the first one, all of them 0 except the last one, and then 1 0 and 1 1 and 1 0 0, 1 0 1, and so on. And up 1,028 or 1,024 different variations will then give me these networking addresses. Yeah, calculating the numbers of hosts that remaining. Well, then now I have a I have borrowed 10 bits. I had originally 24, which gives me 14 bits remaining in the host field. So that is 2 in the power of 14, which is 16,384 minus 2 is 16,384. 382 hosts, valid host addresses per subnet. So these are large subnet. So when we want to subnet, there are two different ways of doing it. Either we can look at the number of networks that we want, or we can look at it in the number of hosts that are required for the new networks, depending on I think the task, because sometimes, for instance, if I were an internet service provider and I handle the public IPs, I need to make the use of the IP addresses most efficiently. So then I will typically look at the number of hosts needed, and I will not waste any IP addresses. If it were a private segment and it doesn't really matter, I just knew that I will now need 8 new networks or 10 new networks, well then I will do it according to the networks needed. But of course also I need to make sure that I had enough room for all my host addresses. So this is here based on the organizational structure of a corporate network where I have private IP addresses. I will typically do it on how many networks do I need. Of course, I also have to remember to look at the future need for networks. So if I had now 8 networks and I borrow 3 bits and creating 8 new subnets, well, I have to keep in mind that at some point I might be needing some more networks. So that could make me want to borrow, for instance, 4 bits instead, so I have 16. So I have room for enlargement of the network. Same thing will apply if I do it on the number of hosts. If I have room for 32 hosts or 30 hosts, I might want to have room for improvements or to scale it up, for instance, on a later time. Yeah, so yeah, in here just an example again of how to borrow, and I can, for instance, here if I have different requirements on different LANs, I can of course do the same subnetting all over and on all my local area networks and look at the largest number of hosts I need, and then I can subnet according to that. The thing is that I might waste a lot of IP addresses again. For instance, here, if I have 5 different networks and there are different, I have different number of hosts in each and every one of them. I also have some networks in between here where I only actually need 2 networks or 2 host addresses because this is a point-to-point network. Then I maybe want to subnet so that I have a /30 address within or between these 2 routers, and all of them actually between all the routers. Traditional subnetting will give me the same subnets on all of my interfaces, and that will of course give me a lot of addresses that I cannot use. So what I will do then now is implement something called variable length subnet mask, which basically means that I can subnet a subnet. So instead of having 30 hosts on each of my point-to-point connections, I can take one of them and I can borrow bits from the new network that I get from subnetting and then subnet it again. I can subnet all I want until I have at least 2 hosts left for the 2 host bits left for the host portion of the IP address. So what I can do is I take the 7th network I get here and then I borrow new, how many? I borrow 3 bits more from subnet 0 and then I get these new networks here as well. So now I get a lot of /30 addresses. I get 8 new /30 addresses. So I can basically subnet a subnet, which is something that I will do in this case here, where I have one IP address that I want to subnet so it will fit the requirements in this setup. So I will have a room for the number of hosts on each building A, B, C, and D, and also I will use the subnet to create networks for my point-to-point connections as well. In this way, I will not waste any IP addresses. And of course, here it's important that the routers can do that, and modern routers today they will support VLSM and can have different subnet masks on different interface without any problem. In the older days, it could be a problem to have these different IP addresses on different interfaces with different subnet masks. So basically, VLSM makes us subnet as already subnetted